The grandest room New York ever built lasted 53 years before the city tore it down. Penn Station's main waiting room ran 314 feet long, with a ceiling 150 feet overhead, and it stood directly on top of a train platform sunk 45 feet into the ground. The room isn't the hard part of this story. The hard part started 6 years earlier, under the East River, where crews were pushing steel shields through mud under compressed air and listening for a whistling sound. A whistle meant the air was escaping up through the riverbed, and the river was about to come the other way. By April 1906, work had stopped on 3 of the 4 tunnels. So how do you get from that to a platform 4 stories underground that was lit like the middle of the afternoon? I went through the original engineering reports, construction photographs, and period trade journals, and used advanced AI to rebuild the whole thing in sequence. 2 rivers, an 8-acre hole in the middle of Manhattan, and nearly 500,000 cubic feet of granite. 3 separate engineering problems stacked on top of each other. By the end, you'll know exactly what was standing there in 1910, including how much of it was actually stone. Before 1901, anyone taking a train into New York from the south had to stop in New Jersey and finish the trip by ferry. The Pennsylvania Railroad wanted direct rail access into Manhattan, and getting it meant tunneling under 2 rivers and clearing space for an entirely new terminal in the middle of the city. The site the railroad chose sat in a dense residential neighborhood nicknamed the Tenderloin, packed with tenements, saloons, and rooming houses across 8 city blocks. Some of those buildings stood barely a decade or 2 old themselves, ordinary tenement housing that had nothing structurally wrong with it beyond sitting on land the railroad now needed. Starting in 1901, a real estate company quietly bought up property across the site, parcel by parcel, before most residents realized a railroad was behind the purchases. Demolition crews eventually leveled roughly 500 buildings across 28 acres to clear both the station footprint and the approach tracks feeding into it, one of the largest single acts of urban clearance New York had seen up to that point. Crews worked block by block, tearing down tenements, stables, and storefronts in sequence rather than all at once, since portions of the site needed to stay clear for early tunnel shaft construction well before the rest of the demolition finished. None of that demolition work solved the harder problem waiting underneath the rivers on either side of Manhattan. Displaced residents scattered across the city with little formal compensation, while the physical debris from hundreds of leveled buildings had to be hauled out before excavation for the station itself could even begin. Contractors reused some of that debris as fill elsewhere on the site, rather than hauling every load away. An early example of construction crews trying to cut costs on a project already running into the tens of millions of dollars. Chief Engineer Charles Jacobs, who had learned shield tunneling in London before crossing the Atlantic to take this job, started work under the Hudson in 1904. The method was a massive circular steel shield, driven forward through the riverbed by hydraulic jacks, while workers inside dug out the face and lined the fresh tunnel with cast-iron segments bolted together ring by ring. Compressed air held the surrounding silt and water back as the shield advanced, sometimes only a few feet a day, through ground the engineers described as closer to soup than soil. Quick pause. If this is the kind of history you want more of, subscribe so you don't miss the next one. And if you're finding this interesting, a like goes a long way. An earlier attempt under the same river in the 1880s had ended in a blowout that killed 20 men and stalled the crossing for over a decade, and Jacobs' team studied that failure closely before settling on their own approach. It worked. Each tube ran nearly 6,000 feet and dropped to about 100 feet below the surface of the Hudson at the deepest point, and on October 9, 1906, the 2 shields met. 2 years and no collapse. The other river took 5. The East River crossing turned out even more dangerous. Chief Engineer Alfred Noble oversaw construction of 4 separate tunnels under the East River, each one roughly 3,950 feet long and 23 feet in diameter, dug simultaneously from both the Manhattan and Queens sides toward the middle. Noble had already built a reputation on major American engineering projects before this one, though nothing in his prior work involved 4 simultaneous underwater tunnels running through ground this unpredictable. Crews pushed 23-foot steel shields through alternating layers of quicksand, gravel, and solid rock, a mix so inconsistent that engineers sometimes had to switch tunneling methods mid-tunnel depending on what the shield hit next. Where the ground turned to rock, workers blasted through it with dynamite, setting charges underwater under compressed air, a process that occasionally misfired. Each of the 4 tubes needed its own dedicated shield crew working independently, meaning the project effectively ran 4 separate high-risk tunneling operations at once, rather than repeating one proven method 4 times. How do you keep a tunnel from collapsing when the ground itself keeps changing consistency without warning? You adjust the air pressure constantly and hope the crew reacts fast enough when it doesn't hold. In one incident, a blowout sent a geyser of mud roughly 40 feet into the air above the East River, killing 2 workers caught in the collapse. More than a dozen sandhogs died over the 6 years it took to finish all 4 tubes. Divers sometimes had to go down afterward to patch the blowout site from outside before tunneling could resume, working in river conditions with essentially zero visibility. This level of danger was just the warm-up act before construction on the actual visible building had even started. Both rivers were finally tamed. The hardest part of the job was still sitting untouched, directly in the middle of Manhattan. With the tunnels finally connecting New Jersey and Queens to a single point in Manhattan, crews turned to excavating the station site itself, a hole that in places reached 75 feet down to solid bedrock. 75 feet down, in the middle of the most valuable real estate in the country. Was there any way to dig a hole that size without the streets above caving in? Steam shovels and horse-drawn carts hauled out hundreds of thousands of cubic yards of rock and soil, opening an 8-acre pit in the middle of one of the densest neighborhoods in the country. Track level would eventually sit roughly 40 to 45 feet below street grade, low enough that everything built above it, platforms, concourse, and the grand rooms up top, had to be engineered as one continuous structure from bedrock upward, rather than a building simply dropped onto existing ground. Rail lines threaded directly through the excavation pit itself, letting crews load spoil straight onto flat cars, rather than trucking it out by road, a logistics setup that had to be reconfigured constantly as the dig moved deeper and the usable footprint shrank. At its peak, the excavation employed thousands of laborers working in shifts around the clock, since a hole this size sitting open in the middle of Manhattan for months on end represented its own ongoing safety and traffic problem for the surrounding blocks. 650 steel columns rose directly out of that excavation, extending from the track level all the way up to support the concourse and waiting room overhead, each carrying up to 1,658 short tons. Architect Charles McKim designed the visible structure to hide almost none of that engineering, letting the steel skeleton show through in the concourse while burying it behind stone everywhere the public was meant to feel awe instead of function. Each column had to be positioned with enough precision to align with both the track layout below and the exact floor plan of the waiting room and concourse rising above it, a 3-dimensional puzzle worked out almost entirely on paper before a single beam went up. Any error compounded upward through the entire structure, since a column set even slightly out of position on the track level would throw off wall and window alignment several stories above it. The hole was finally dug. Now somebody had to make it look like ancient Rome. Above the steel frame, McKim wrapped the 7th Avenue facade in Doric columns cut from pink granite quarried in Milford, Massachusetts, roughly 300 miles from the construction site. The finished colonnade used 84 columns in total, some accounts describing the full facade as stretching nearly 450 feet end-to-end, modeled loosely on the Acropolis in Athens, filtered through a distinctly Roman sense of scale, though built at a scale the Acropolis itself never attempted. Each column block traveled by rail from the Massachusetts quarry to Manhattan, then had to be lifted into position using derricks anchored directly into the rising steel frame, since nothing lighter could handle stone sections weighing multiple tons apiece. Stonecutters shaped the fine surface details, capitals, and fluting after the raw blocks reached the site, rather than finishing everything at the quarry, since transporting fully finished columns risked chipping the delicate carved edges during the rail trip south. A single Doric capital alone could take a skilled carver days to finish by hand, work that had to happen close to the installation site rather than at a distant workshop. Crews used roughly 500,000 cubic feet of granite across the entire building, along with 27,000 tons of structural steel and 17 million bricks, materials arriving on a schedule tight enough that masons were often setting stone on one part of the site, while steel crews still worked sections nearby. Coordinating that many separate material deliveries without a single modern logistics system meant relying almost entirely on rail schedules and site foremen tracking deliveries by hand, matching incoming stone shipments to whichever section of the facade was ready to receive them that week. A delayed shipment on one side of the site could stall an entire crew for days, since substituting a different batch of granite risked a visible color mismatch across the finished facade. The waiting room was the payoff for everything buried underneath it, and when it opened, it was the largest indoor space in New York City. The finished room ran 314 feet long, 108 feet wide, and 150 feet high, sitting directly on top of tracks sunk 45 feet into the ground. McKim built it out of Roman imperial bathhouses, Caracalla above all, and the Pennsylvania Railroad advertised the stone as travertine, cut from the same Italian quarries that supplied the Colosseum and the Pantheon. It was the first major American building to use travertine at all. Here's what almost nobody catches in the photographs. The travertine stops. Real stone runs up the lower walls, across the pedestals, and up the Corinthian columns standing 60 feet from base to capital. Above that line, the room is a steel frame hung with plaster, painted and tooled to match the masonry underneath it. Rebuilding the wall-in section makes the handoff obvious, a horizontal seam roughly a third of the way up, where stonecutters stop and plasterers take over. From the floor, 100 feet below, the eye reads the whole wall as one continuous piece of quarried rock. The ceiling worked the same way. Workers coffered it into a grid of recessed panels, a pattern lifted straight off actual Roman bath vaulting, and every panel they sank pulled weight off an overhead surface already spanning an enormous open room. Decoration doing structural work. Above the columns, more than 100 feet up, Jules Guérin filled 8 lunettes and 6 panels with murals 25 feet tall and 70 feet across. They were maps. The railroad painted its own route network onto the ceiling of a Roman bath and let people wait for their trains underneath it. So the grandest room in America was part quarry, part plaster, part advertisement. And it worked, because the illusion was engineered as carefully as the steel holding it up. Where the waiting room aimed for stone and shadow, the train concourse just beyond it aimed for the opposite. Could steel and glass really hold up a roof spanning open platforms 4 stories underground without a single load-bearing wall to lean on? McKim's design shifted from solid masonry to an open lattice of steel arches and glass, a structure closer to a European train shed than anything else built in New York at the time. More than 83,000 square feet of skylights covered the concourse, engineered specifically to pull natural daylight down to a platform level sitting 4 stories below street grade. That glass canopy meant passengers walking to catch a train never fully lost daylight, even while standing on a platform buried deeper underground than most subway stations of the era. Getting that much glass and steel to hold its shape meant a lattice of riveted trusses spanning wide-open bays, without a single load-bearing wall interrupting the platforms underneath. Crews assembled the steel arches in sections, riveting them together on site rather than casting single massive pieces, since no crane or derrick available in 1908 could lift a finished arch span of that size in one piece. Ironworkers bolted temporary supports beneath each arch section, while riveting proceeded overhead, only removing the falsework once an entire span could support its own weight independently. The bones of the building were finished. What it still needed was a face. Finishing touches went up last, including 22 eagle statues by sculptor Adolf Weinmann, perched along the building's cornice and flanking its main entrances, carved specifically to echo the same Roman military imagery running through the rest of the design. Each bird weighing thousands of pounds and requiring its own dedicated lift to the cornice. Weinmann modeled each eagle individually rather than casting identical copies from a single mold, giving the birds along the cornice slightly different poses depending on their position relative to the street below. I love that Weinman refused to just mass-produce identical birds, sculpting each eagle slightly differently, even though almost nobody standing on the sidewalk below would ever notice the difference. Both Alexander Cassatt, the railroad president who pushed the project through, and Charles McKim, its architect, died before construction finished, in 1906 and 1908. Neither man saw the finished waiting room, the completed colonnade, or a single train pull into the station either of them had spent years fighting to build. The Long Island Railroad began running trains through the finished tunnels and station on September 8, 1910. Full service opened on November 27, 1910, and more than 100,000 spectators reportedly passed through that first weekend alone, walking across a floor that had been open excavation down to bedrock just 6 years earlier. Visitors that first weekend reportedly wandered the concourse and waiting room simply to look up, since nothing else in the city offered a ceiling this high built this far below street level. None of what stood there in 1910 was accidental, and not all of it was even real. Granite where the building met the street, travertine where hands and eyes reached, painted plaster everywhere above that, and glass wherever daylight had to be dragged 4 stories down. Every one of those choices was engineering, including the ones designed to be mistaken for something they weren't. That's what the 2 rivers and the 8-acre hole were ultimately for, not the tunnels themselves, and not the colonnade. Just the moment a passenger walked out of an arcade into a room the size of a cathedral and never once thought about the mud 60 feet below them. It stood for 53 years. When it came down in 1963, the Eagles survived, and 2 of them still sit on 7th Avenue flanking the entrance to the station that replaced it. So did something easier to miss. Stand on the platforms today, look up, and there are still glass panels set into the ceiling above you, left over from when daylight came down through them from a roof that no longer exists. Subscribe if you want more vanished buildings rebuilt piece by piece like this, and tell me in the comments which one I should reconstruct next.